The macroscopic properties of an ideal gas are its volume, temperature, and pressure. Their empirical relationships can be defined by the ideal gas law. There are two versions of the ideal gas equation, so I want to break it down for you and look at the differences between them. We begin by remembering that the pressure multiplied by volume and divided by the temperature of an ideal gas is always equal to a constant. So PV is some constant multiplied by T. There are two main versions of the empirical ideal gas equation depending on which constant we use. We usually use the version where the constant is small n times R. This gives us the equation PV is nRT. Small n is the amount of gas in moles. R is the molar gas constant, equivalent to 8.31 joules per mole per Kelvin. I can also write the constant as capital NK. So this gives us PV is NKT. Capital N is the number of molecules in the gas. And K, that's the Boltzmann constant, 1.38 times 10 to the minus 23 joules per Kelvin. You might also find it useful to remember that NR is equal to NK. I'll rearrange this to make Boltzmann constant the subject. But we do know that we can calculate the number of molecules in a gas by multiplying the amounts of gas in moles by the Avogadro constant. Let's substitute it back into this, and we have found an expression relating the Boltzmann constant and the molar gas constant.